Our next lesson in geometry is called the nature of mathematics, but let's review a little bit first. Since we are created in the image of God, we have the capacity to blank and blank. Okay. You should have said think and reason. Try to answer these before I do. According to the Bible, we are to glorify God, subdue the earth, and rule over His creation. True or false? True. We are to be blank of God's creation. Stewards. Since we can think and reason, men have invented and created blank and blank. Language and abstraction. Man has converted blank, involving magnitudes and relationships between the figures and forms we see in creation, to a blank that enables us to communicate with others about the ideas and abstractions that we are thinking. I said man has converted blank, involving magnitudes and relationships between the figures and forms we see in creation. What would that one be? Okay, you should have said patterns. Man has converted patterns between the figures and forms we see in creation into a blank that enables us to communicate with others about the ideas and abstractions we are thinking. That would be what? Language. What has mathematics become to mankind? A tool. True or false? God made you to glorify Himself. True. God made creation and it glorifies Him. True. God gave a directive to mankind. True or false? True. Psalms 19 specifies that what? The heavens declare the glory of God. Genesis 1:1 and Revelations 4:11 describe the fact that God what? God made creation and it glorifies Him. The connection between man and creation discussed in this section is the tool called what? Mathematics. Okay, let's look at today's lesson. Today's lesson is called Nature of Mathematics. Our goals for this lesson are to restate important aspects of the nature of mathematics and to explore the relationship between the real world and the world of ideas. Okay, I want you to go wherever you're at in your notes. Do not go to a new page. I just want you to skip a space wherever you're at. I want you to put today's date. Remember, don't rip any pages out of your notebook. This is Nature of Mathematics. I'm just going to put Nature of Math. Mathematics uses numbers to express the interaction between the abstract ideas of our minds and the concrete things of the world. Okay. Okay, so mathematics uses numbers. And numbers express the interaction between the abstract and the concrete. So it kind of bridges the gap between abstract ideas and concrete things. Mathematics uses two basic areas. Pure mathematics, which is abstract ideas, thoughts and creations in my mind and the minds of others, and applied mathematics, which is concrete ideas, real-world problems, implies problem solving. So mathematics has two major areas. Two basic areas. Okay, one is pure mathematics. Pure mathematics, and this is abstract ideas. If you can touch it, it's concrete. If you can't touch it, it's abstract. Abstract is like your ideas. And applied mathematics. And applied mathematics is the concrete. Okay. Mathematical thinking. When we face a real-world problem or event, we begin to solve the problem by collecting data about it. We make observations, sometimes again and again. We gather the information and begin to record it in some way. Later, we may begin to perform operations with the data to help us discover a pattern. Then we begin to classify the patterns we see into our sets and collections. From these patterns and collections, we begin to make inferences about what we see. In other words, we're beginning to make sense of the problem. We are solving it. When we do these things, we are thinking mathematically. Besides the activities taking place in the real world, there are activities taking place in the ideal world, the realm of our mind. As we begin performing the activities mentioned in the previous paragraph, our minds are swirling with thought processes. Is there some sort of mathematical formula, theorem, postulate, or rule that can be drawn upon? Should I multiply then add, or should I divide then subtract? Aha! Such and such a formula and procedure will work here. In our mind, the process could involve calculations, formulating hypotheses, or following a certain logical process. Maybe we are conjecturing, testing, or coming up with a generalization. In all the activities mentioned above, we are thinking mathematically. When we think mathematically, there is a rapid seesawing between the real world and the realm of ideas. This seesaw effect is how pure mathematics and applied mathematics were developed. Pure mathematicians are interested in the abstractions of mathematical systems. Okay, they're interested in the abstract, the mental processes involved, or the creation of the symbolism in which we communicate these ideas. They are delighted, however, when a mental abstraction can be used to solve or be applied to a real-world problem or event. Likewise, applied mathematics are connected with the present problems and events that we deal with on a daily basis, which are concrete. Generally, these mathematicians are engineers, carpenters, mechanics, medical technicians, or anyone else using mathematics in a practical way. Sometimes the observations of the practical users of mathematics have also been used to encourage the pure mathematician to find new patterns or abstractions to help explain observed occurrences. This has been particularly true since the advent of powerful computers. How then do we communicate mathematically? By using symbols, linked together by reason and logic. They have common meaning among people. In fact, mathematics is sometimes called the universal language. Okay. Mathematics is the universal language. Okay, we said that numbers express interaction between abstract and concrete. There are two basic areas of math. There's pure math, which deals with abstract things like ideas, and there's applied math, which is the concrete. Mathematics is the universal language. Things to remember. Thinking mathematically is the process of modeling the real world in an abstract manner, being able to see how an action in the real world will be reflected in our model, and how changes in our model can be used to predict events in the real world. This is the glue between pure mathematics, working with the model of the real world, and applied mathematics, working in the real world to solve problems. Pure mathematics involves the abstraction of mathematical systems, the mental processes involved, or the creation of symbolism used to communicate the ideas. Applied mathematics is concerned with the present problems and events that must be dealt with on a daily basis, and we communicate mathematically using symbols, reasoning, and logic that have an understood meaning. Okay, I want you to go through and review this lesson and go ahead and answer the questions.